Good morning everyone, and a very warm welcome to the University of Southampton. And more importantly, welcome to the Kickstart for Student Robotics 2025. This marks the official beginning of this year's competition cycle. And let me tell you, it is fantastic to see a number of you here today. Also, thank you very much to everyone who's joined us on the live stream. It's fantastic to see so many of you in there too. My name is Anton, and over the next hour or so, I'm going to be talking you through all the information that you'll need to know about what's going to happen. So let's just jump straight into the agenda. First of all, we'll talk about what is student robotics. No doubt some of you who have competed before, or who are part of teams that have competed before, know who we are and know what we are all about. However, this year we are lucky in that we have a number of rookie teams that have never competed before. So in this section, we'll be introducing ourselves to you. Next, we'll outline the schedule for the year, because you want to know what's going to happen when. Next, we're going to talk about your robots. We'll give you tips around building your robots. We'll talk about developing your robots, so writing code and doing electronics. Obviously, we want you to have fun, but above all else, we want you to be safe. So we're going to give you some very handy health and safety tips. Then we'll talk about the game, which is what your robots will be competing in. And finally, we'll round off by talking about the Microgames, which are activities that you'll be participating in to get familiar with the kits in the latter half of the day. Now, as I said, I'm going to be talking at you for about an hour, and no doubt over that time, you're going to have questions that will come up. So what you can do is you can scan this link, and at the end, we'll open up the question session, and you'll be able to ask any questions that you have. If you're joining us on the live stream, we're going to post this link in chat for you. I'll just pause for a second so everyone can get the link, and so everyone on the live stream, if they want to get the link as well. So, first of all, what is student robotics? Well, we are a UK-based charity with a very simple mission: to bring the excitement of engineering and the challenge of coding to young people through robotics. We do this by running an annual autonomous robotics competition. So this means the robots you create will not be controlled by you in any way. The teams are comprised of mainly 16 to 19-year-olds. And the charity is run entirely by the volunteers, or the blue shirts as they're named because of the blue shirts. We give our free time to make all of this possible. There are quite a few of us, more than are shown in the picture above, which was taken at last year's competition. And as you can see, we have a lot of fun doing this, and we're very happy to help. But there's also a critical component to this, and that is you guys, the teams. Your team supervisors, your teachers, and your parents, who no doubt will be supporting you over the next year as you build your robots. So where are you guys from? We have about 30 of you, and there's quite a variation. As you can see, a few of you are mainly based around the south of the UK. We have a few in the Midlands. We have a team from North Wales. And we're also very lucky to have two returning overseas teams, namely Team Gymnasium Markt Indersdorf from Germany and the Ladies College from Guernsey. So for those of you who aren't too familiar with what a student robotics game looks like, let's give you a quick taste of what is to come. Oh, I thought this had happened. The video is not working. There you go. Right, so this video was taken at the competition final for Student Robotics 2022. And in that year, the teams were tasked with designing a robot to retrieve cans from the center of the arena and take them back to their home zone in order to score points. There was also an added mechanical challenge involved in that to score extra points, they had to design a mechanism such that they could rotate the cans 180 degrees, such that the orange tape that you can see over there was facing the bottom. Now this year, the game will not be this. It changes every year, but some things will remain similar. For example, there will be this similar sized robots. The arena will look the same, and the length of time of match will be about 2.5 minutes. So as you can see, there's quite a lot going on here, and this will be you in about 6 months' time. So to reiterate, you only have 6 months to design, prototype, build, do all of the electronics for, hopefully a bit better than this image here. Basically, we don't want it to look like a pigeon has made its nest in it. You're going to write lots of code. You're going to test your robots. You're going to test it some more. You're going to test it a bajillion times, which, by the way, yes, that is a technical term. You're going to work as a team. When you come to the competition, you're going to get your robot inspected to ensure it complies with our very stringent health and safety requirements. You're then going to compete. You're going to compete some more. You will compete even more. Over the 2 days of the competition, there are about 150 robot matches split between the league and the knockouts. That's a lot of robotics. You're going to meet other robots. You're going to meet other people. You're going to hopefully score some points, hopefully win some prizes, and above all else, have fun. Yes, student robotics is tough, but it is very rewarding. So now that we've talked about what you're going to have to do over the next half a year, let's dive talking into what your robot could look like. So as we've seen, all robots themselves are they come in quite a variety of form factors. Some look like boxes. Some look very versatile. Some look like cars. Some look like car washes. And some look like spiders. Thank you, John Bartlett from our team in North Wales, for gracing us with this lovely design. And really anything else. The limit here is quite literally your imagination, and of course our health and safety rules. But as long as those two marry up, it's all peachy keen. So let's go over some design tips, first of all, from a mechanical point of view. So above all else, and this applies to other sections as well, read the rules. They are very helpful as they give you the constraints that you have to work within. First of all, you're going to want to think about movements. And there's quite a lot of options here open to you. So you could have a robot with wheels. You could have a robot with tracks, meaning tank treads. Or as we saw in the previous photos, you could have a robot with legs. You're also going to think about how to achieve accurate movements. So for instance, if we take the example, if you have wheels attached to motors, what you may find is that 2 motors running at full power may not necessarily spin at the same rate. So when you come to code your robot, and we'll talk about that a bit later, you might have to account for this. And as tempting as it may be to whack everything up to 100% and drive around the arena, this probably isn't a recommended strategy, because when things happen quicker, they are harder to control. So you'll have to take these things into account. You're going to have to think about what mechanisms you want on your robots. In particular, if any of them are exposed, this could lead to a problem where they could get caught on other robots, the arena, volunteers who have to occasionally handle them. So what I'm saying is that exposed mechanisms are generally bad. You're going to want to think about couplings, as in how things fit together. You can't just hold up 2 bits of board and expect them to magically fuse. You're going to have to think about how they all attach. As we said, robots come in all shapes and all sizes, but there's still a constraint that we place upon you, and that is detailed within the rules. And by the way, we do check for this when you come to the competition with our patented cube of judgment. And finally, you're going to want to think about tooling. So what tools do I need to achieve the mechanisms that I want to build? So now that I've covered some tips from a mechanical point of view, let's now talk about electronics. As a minimum, your robot is going to have our kit on it, and that is electronics. So you're going to have to think about where are these electronics going to go, such that you can A, get to them easier, and B, that they're not at risk of getting knocked off inadvertently during a match. You're going to think about what sensors do you want, as these are how your robot will be able to read the environment around it. And there's quite a range of options here as well. You could have vision, you could have bump sensors to detect whether or not you've hit into something. You could have a light gate to determine whether or not something has crossed the threshold. There's a wide range of options available, and they all have their merits. Another thing that you're going to want to think about is how long should your wires be? Primarily because wires that are really long can increase the likelihood of them getting tangled and will make debugging a lot harder. We'll talk about this later during the health and safety, but you're going to want to make sure your start button, which is how you start your robot code running, that needs to be accessible. We haven't mentioned how code gets onto your robot, but spoiler alert, it's on a USB stick. This needs to be accessible for you too. And finally, the battery that we provide you, which powers your whole kit, will need to be protected. So, we've been doing this for quite a while, I think about nearly 20 years at this point, and we have some recommendations and tips that we've picked up along the way. So first of all, you're going to want to start simple. Get a test space working as soon as possible. And this could literally be a block of wood or a cardboard box with the kit stick on it and motors and wheels, just so you have something from which you can build up from. You're going to want to think about game strategy and what mechanics you might need to help with that. So for example, if your strategy relies on you driving around the arena and picking up various props, you're going to want to think about what kind of lifting mechanism you would want. What feeds into this as well is sensors. What kind of data do I want to read from my environment? And then you're going to want to iterate. And there's a very simple 3-step loop that you can go over. And that is, make a change, test it, make improvements. And you're going to want to go over that again and again. So you make a small change, test it to make sure it works, figure out any improvements. And as you do that, the complexity of your robot will build up gradually until you have a fully fledged design. And testing. You're going to want to do lots and lots and lots of testing. By the way, did I mention testing? So we're kind of laboring on this point quite heavily, but testing is absolutely critical. You need to know how your robot is going to perform in the real world. And what we find is that teams who test their robots more frequently, particularly at the competition, tend to do better. And on a related note, you may have noticed in your kit that you have a square of carpet. This might look familiar to some of you. This is the carpet from the arena from last year. And we'll be using a very similar material again this year. And the reason we provide this to you is so you can see how your robot can drive on a similar real-world environment. So now that we've outlined some design tips with regards to building your robots, let's talk about what you're going to use. We provide you with our super high-tech kit, which makes getting up and running super simple. We're not sending you in empty-handed. The first of this is the brain board, quite literally the brains of this whole operation. This board controls all the other boards in your kit, and it is from where your code will run. It's a Raspberry Pi 4 with a KCH Pi hat, which has a number of controllable, of course, RGB and other status LEDs that may assist with debugging. We have the motor board, which is aptly named because it controls motors. And you may notice on the slide here, we don't provide you with motors. However, if you need some assistance on where to source them or which ones to buy, feel free to ask, reach out to us on Discord. We'll be more than happy to help. There's also the servo board, so called because it controls servos. These are very useful if you want to achieve very fine control with mechanisms. But you want to be a bit careful with how you load them. So what I mean by this is that if you try and pick up things that are really heavy with some servos, that could cause them to draw a lot of current, which could affect other parts of your kit. Next, we have the power board. and this is responsible for distributing power to all other parts of your kit. The key point here is that it has various outputs for connecting to other parts of your kit. It has an on-off button, of course, the start button that gets your code running, and it also has a buzzer, so if you want to play some absolutely funky tunes, or you want to maybe use it for debugging during your robot development, you can do that. So how does the power board itself get power? Well, we provide you with a battery. Now this slide is called orange. It's coloured orange because LiPo batteries, as these are called, should be respected and treated with care. If they are inadvertently damaged or charged incorrectly, there is a risk that they present a fire hazard, so we do want you to be really careful when using them. You must follow the battery charging procedure to the letter every time. And in fact, this is one of the microgames that you'll be participating in later. Only ever connect the battery to our power board and our supplied charger. As I said again, and I'll probably repeat it later, you must protect the battery from any mechanical damage. Do not over-discharge the battery. And finally, if you're unsure about anything, your first port of call should be the docs. You can also reach out to us on Discord. And the final board that I will talk about is the Arduino board, which provides what's known as general purpose input-outputs. You may also hear it be called GPIO. And this board is into which you will connect all of your various sensors. And it's just from this board that you can get the information from them. As I said earlier, there's a wide array of options available to you: bump sensors, light gates, pressure sensors. A notable point here is that the only sensor that we provide to you in your kit is the ultrasound. So again, if you want any more information about which ones to source and which ones are the best to use, you can reach out. Now, another piece of kit that you may have seen in your box is a camera. And this is part of the robot's vision system. But what exactly is this used for? So as you can see in the photo above, and as you may have seen in the video at the beginning of this presentation, there are these QR code-esque looking markers dotted around the arena. So what are they exactly? They're not exactly QR codes. They are known as fiducial markers. And they're a bit better because not only do they provide data, i.e. just one number to identify what the market is, but positional information as well. So what I mean by this is that if your robot takes a photo and in that photo is one of these markers, it can use some pretty clever maths to determine how far away am I from that marker, and at what angle am I relative to that marker. So you can use this to carry out some pretty sophisticated control strategies in your code. So now that we've talked about your kit in isolation, what does it actually look like when it's all connected together? Well, here we go. You can also find this picture as well as a very helpful video on how to assemble on the kits on our website. So you've connected all your kit together. You've figured out what sensors you need. The next step is to actually mount it to your chassis. And we have some tips around here as well. First of all, screws. They're great. They're really good for securing various bits and pieces of kit and mechanism to your robot. The one thing we do ask is that if you do intend to screw our kit onto your robot, please only use the screw holes that we provide. Don't introduce any new ones. And similarly, Velcro and cable ties, both very good options. In terms of things you should avoid, gravity. We shouldn't be able to pick up your robot, flip it over, and all your kit fall out. And in general, any adhesives such as hot glue, PVA, or blue tack, because this really gunks up our kits. So now that we've covered the kit, let's move on to talk about your code, which is the brain of your robot. So your code will be written in Python. We think it's a lovely language. It's quite easy to get up and running in. We provide you with a module that provides all the functionality that you will need to talk to other parts of our kit. So it makes it really easy to do stuff like turn motor 0 on motor board 1 to 100. The development for this year will be local, i.e. you guys will do all the development, we do not have access to it. And as such, that means we don't actually place any restrictions on what code environment you want to use. So if you're like me, you can use VS Code. Some people might use Notepad, or if you're that way inclined, Vim or Emacs. It's up to you, really. Make sure you take backups of your code, because, as I say, we don't have access to it, so if anything were to go wrong, we won't be able to help you. You're going to want to think about how you can work as a distributed team. And what I mean by this is that not all of you will be in the same place at the same time, but you may want to work on the same parts of the code or different aspects of it. So you may want to think about how you might achieve this. So for instance, you might use version control. And if you're not familiar with this term, or you want to find out more, feel free to ask us. You're going to want to think about code structure. Well-structured code means that it's easier to debug and maintain in the long run. So for example, are you going to have your code in one big file, or are you going to split it up into lots of smaller modules? In general, I'd argue that the latter is a bit better because it becomes more manageable and makes it easier to maintain. And finally, for those of you who are interested, on the Brainboard, we do provide some pre-installed libraries that will help with coding functionality, such as the standard library and some other helpful third-party ones as well. So now that you've written your code, how do you go about taking that and putting it onto your robot? So as I alluded to earlier, there's a USB stick involved. You'll have a file called robot.py. I need to add that that isn't the only file that you need. It's just what the Brainboard will look for when it comes to start your code. So you take your code in robot.py, you put it on a USB stick, you plug that USB stick into your robot, you switch it on, you wait for the start button to start flashing, you press go, and away it goes. And another particularly useful feature of the Brainboard is that it emits a Wi-Fi signal that you can connect to and log into the web interface. And this is a really handy tool because it provides, firstly, live logs. What this means is that you can view what your code is doing in real time. So if any errors occur, you will know about it. Or if you've put any debug statements into your code, they will come out here as well. This also provides the facility of live camera capture. So what this means is that you can view images the camera is capturing as they happen. It also provides the facility to easily start and restart your robot, so you don't have to constantly plug your USB stick in and out. And of course, we have dark mode because we're developers. And for those of you who are returning this year and may be interested to know, our kit team has been working really hard this year to bring a few changes to make things much easier. So firstly, we have out-of-box ultrasound support with new Arduino firmware. We've updated our Vision API to improve debugging. We've done some fixes for the USB hub connection issues. And we've also rewritten the simulator with new installation instructions. So if you want to find out any more information, or you're just curious, you can go to the docs, which is on the URL above. So, as I mentioned at the beginning of the talk, we want you to have fun, but above all else, we want you to be safe. And when you come to the competition, we will inspect your robot before it is even allowed to compete. And these are some of the criteria that we'll be looking out for. First of all, is the power button accessible? This is crucial because in the event that your robot starts behaving erratically in the arena and could therefore pose a danger to itself or other robots, we will need to get in there quickly in order to turn it off. So this must be made accessible. Secondly, if we pick it up, can it hurt us? And also, can it hurt you? We don't want that to happen. So make sure that any mechanisms that you make or any corners that you cut don't have anything sharp. Thirdly, is the wiring messy or loose? As I was talking about in the electronics section, having messy wiring increases the likelihood of them getting caught on other mechanisms, which could damage your sensors. It also makes it harder to debug. So one thing that you can do, a tip that we give, is color code your wiring. The most common scheme here is red for power, black for ground. But you also might consider color coding certain sensors on certain parts of your robot to make debugging a lot easier. Is the kit loose? As in, if we pick it up and shake it, are things going to fall off? But this is also particularly important because during a match, robots do sometimes collide, and we don't want your kit falling off into the arena and causing debris. And finally, I've said it twice already, but I'm just going to say it a third time for good measure, is the battery protected? We don't want anything sharp causing damage to the battery. So this is a key point that we'll look out for. So we've discussed your kit, some design tips, and also the kit that we provide. Let's now go over the schedule for the year. So, starting over here on the left, we are at Kickstart. On this side of the year, we have some tech days and challenge deadlines, which we'll talk about in a bit more detail in a bit. In the early half of next year, we have the virtual competition, some more tech days, and some more challenge deadlines. And the competition is going to take place in early April. And what we can say is that the provisional date for SR2025 is the 12th to the 13th of April, hosted here at the University of Southampton. We'll be sending you more information as the time comes closer. So one thing that you may have seen up there are tech days. So what are they exactly? Well, these are very useful because they are day-long robot hacking events, meaning you bring your robot to a building and you can spend all day hacking on it. There will be volunteers there to assist you with any tips that you might want to ask about. But also, it allows you the opportunity to see what other teams are up to. In terms of our support, where can you go? As I said, you can ask the blue shirts, the volunteers. We've been doing this for a long time, and collectively, we have a lot of experience between us. There are the tech days. There's the Discord, which hopefully you should all have been invited to. The Discord is also nice because not only can you interact with us, you can interact with other teams. So if you want to brag about how good your robot is doing, you can put it in there. You also have your team supervisors, who are there to mentor you, but not necessarily do all the work for you. We caution you and suggest you might want to stay away from ChatGPT and other large language models. And the reason why we say this is, yes, we see people trying to get help from them, but what ChatGPT is very good at doing is sounding really convincing even when it's wrong. So it could lead you down false paths. Some more general advice. Sharing knowledge is important. So what I mean by this is don't silo yourself away and only work on one part of your robots. If you're doing coding, get involved with the mechanics. If you're involved in mechanics, get involved with the electronics. Mainly because you guys have an absolutely amazing opportunity over the next 6 months to learn a variety of new skills. But also, and this is another crucial part, if, for whatever reason, one of your team members becomes incapacitated or is otherwise unable to carry on participating in the competition, having shared your knowledge among yourselves, the rest of your team will be able to pick up what needs doing and carry on the developing of your robots. So I've just given you a lot of information. I'm about to give you a whole lot more because we're going to be talking about the game, which is the moment that you've all been waiting for. And this year, the game is called Urban Heights. And just like last year's competition, we have a backstory for this. In Urban Heights, you've been hired by the city to shape its skyline. Your mission is to deliver vital pallets of building materials to designated districts. But that's just the beginning. If you're up for the challenge, dive into constructing multi-story marvels for even greater rewards. The city is counting on you to build its future. So now that we've run through that backstory, let's introduce you to what the arena will look like. This is a scene that some of you may have been familiar with if you've competed or if you took part in the pre-Kickstart activities, helpfully put together by one of our volunteers, Andy. The objective of the game this year is to retrieve pallets, and the pallets in this picture are the various coloured boxes that you can see dotted around the arena, and place them in the districts. And the districts are the white squares that you can see placed around the arena. There are also high-rises, raised podiums, in the inner 4 districts and the middle. We'll talk about what all of this means in detail now. So now that I've introduced to you what the arena will look like, how do you go about scoring points? Well, first of all, you get 1 movement point for leaving your home zone. So the home zones are these 4 boxes marked now. They are coloured according to your team's colour. You get points for placing pallets in a district. And also, the bonus points, if your pallet is the highest in a district, it doubles your points for that district. So let's go into a bit more detail. We'll first talk about the 4 outer districts. Pallets in these districts are worth 1 point each. Next, we have the 4 inner districts. Pallets in these districts are worth 2 points each. And finally, we have the centre district. Pallets, i.e. boxes, in this district are worth 4 points each. Now, I've said the word in a district quite a few times, but what actually counts as in a district? And this is shown above here. If we read the technical definition from the rules, pallets are in a district if their vertical projection is fully within the district. The tape denoting the district is also included in this area. So basically, what it means is that the pallet box must not be outside the outer line of tape. So as you can see, the pallet on the left is clearly within the district, but the pallet on the right will not be counted because its left edge is outside of the outer tape. So just to summarise, we have 3 districts, outer, inner and centre, worth 1, 2 and 4 points respectively. The highest pallet in a district doubles your points for that district. And you get 1 movement point for leaving your home zone, so the coloured areas on all 4 corners of the arena. Now, what do I mean by highest in a district? Well, let's look at an example. On the left here, Team Green has the highest pallet, and therefore Team Green's points will double for that particular district. We'll run through what scoring will look like in a bit. The situation on the right is describing a scenario where 2 teams have pallets of the same height. For this, we don't consider anyone to have the highest pallet, and therefore no team's points are doubled. So we do have some exclusions to determine what is considered the highest in a district, namely the pallets can't be on the floor, so the one on the left won't be considered to be the highest because it's on the floor. And secondly, the pallet must not be touching a robot. Now I'm going to bring back the high rises that I mentioned earlier, and these are special because the tops of these high rises aren't considered to be the floor, so they can be used to help you gain height to achieve the highest pallets designation. And the dimensions of them are displayed above. All other dimensions, such as the height of the pallets, the size of the arena, the size of the markers, are in the rules. So let's run through some scoring scenarios. Firstly, we're going to consider a situation of a robot in one of the outer districts. So just to remind you, the points here are worth the pallets here are worth 1 point each. So for this scenario, Team Yellow gets 1 movement point because they successfully moved outside of their home zone. And they get 1 point for having a yellow pallet in the district. So the final score in this scenario for Team Yellow is 2. So you have district points, so 1, and then a movement point, 2. Let's move on to one of the middle districts. So just as a reminder, the pallets in this district are worth 2 points each. Let's first consider what Team Yellow's situation is. Again, they'll get 1 movement point for moving out of their home zone. They will get 4 points because they have 2 pallets within one of the inner districts. And also, because the middle pallet is on one of the high-rises, it is considered to be the highest in the district. And thus, the points for Team Yellow double for that district. So, 4 points for 2 pallets, it gets doubled up to 8, plus 1 movement point is 9. Let's have a look at Team Pink. They get 1 movement point, and they only get 2 points for having 1 pallet in the district. So their points for this scenario is 3. Now, you might be thinking to yourself, hey Anton, what if Team Pink pulls off some absolutely spicy maneuvers and slaps their token on top of Team Yellow? How does that change things? Well, here's a scenario, let's run through the points. Team Yellow, 1 movement point. They still get 4 points for having 2 pallets in the district. But notably, they have lost the highest pallet designation because of the shenanigans that Team Pink has gotten up to. So their final score has gone down from 9 to 5. If we look at Team Pink's scenario, they get 1 movement point. They still get 2 base points for having 1 token within one of the inner districts. But because they now have the highest pallets, their points double. So their district points go up to 4, plus 1 movement point, that's 5. So you can start thinking about here what sort of game strategy you might want to employ in order to take points from other teams. And finally, just to round it off, let's take a look at the situation in the center district, where teams green and orange have both managed to get 2 pallets at the same height placed into the zone. Again, they both get 1 movement point. They get 8 points because pallets in this zone are worth 4, and they have 2 of them. Each team has 2 of them, so that's 8. So the final score in this scenario is 9. So now that we've ran through the game and some scoring scenarios, let's move on to talk about what the competition this year looks like. Well, it's split up into 4 phases. We have the challenges, the virtual competition, and when you come to the physical event in April, we'll have the league and the knockouts. Let's talk about the challenges. These are small tasks that we give you that give you an opportunity to earn some league points early. And this is crucial because when you come to the physical competition, the league points are used to determine who you face in the knockout rounds. So it's quite important to get as many league points as you can. We have 3 challenges this year, and they are movement, mechanics, and sensing. You can complete these in any order, and the specifics for these challenges are in the docs. We do have some deadlines for these if you want to earn points. You get 6 points per challenge, and ideally you should get your first challenge done by the first deadline, the 7th of December, a second challenge done by the 2nd, and the third challenge done by the 3rd. Next, we have the virtual competition. This is a simulated version of the physical game that you'll be participating in. Again, it's another opportunity to earn league points, but also it's an opportunity to refine your game strategy. This event will be live streamed and it will take place in around early mid-February 2025. Again, we'll be communicating details to you as we get closer. So what's at stake here? It is a competition after all. Well, we have prizes. Obviously, we have first, second, and third place given to those teams who get those positions in the knockout rounds. We have the Excellence in Engineering Award. This is awarded to the team that displays the most extraordinary ingenuity in the design of their robots. It's not awarded merely for complexity of design, but rather elegance, simplicity, and good engineering. We have the Rookie Award, awarded to the highest placed rookie in the league. And as I said at the beginning of the talk, we have a number of rookie teams this year, so competition for this award might be a bit higher. And finally, we have one of penultimately, we have one of my favorite awards, and that is the Robot and Team Image Award. This is given to those robots and teams who are looking sharp. This is a particular favorite of mine because we are always impressed seeing the effort that teams go into to theme their robots and theme their costumes, and we want to recognize that. And finally, we have the Online Presence Award for those teams who are active online. And if you want to partake in this, you can use the hashtag #SRobo2025. Our marketing team will be able to pick that up and share that far and wide. If you want to read about any of this in depth again, you can do so by going to the rules, which is on the Student Robotics documentation website. So finally, before we open up for questions, we'll talk about the microgames. So these are a series of challenges that get you familiar with our kits. There are two parts. We have the kit parts and we have the simulator parts. The information for these can be found in the docs. Your team supervisors, as well as blue shirts, have the answers. And again, if you're joining us online, you can ask us in Discord for these answers as and when you complete the challenges. So we have reached the end of the information. What we're going to do now is we're going to open the floor to any questions. I have now enabled the questions to anyone. As we're waiting for questions to come in, does anyone have any immediately from the outset? My mic just fell. I'm just going to hold this now. Anyone got any questions? Yes. So the question was, what are the dimensions of the arena? I don't know it off the top of my head. You can find them on the rules, unless any of our 5.75 meters squared, as answered by Jake very helpfully. Thank you very much. Yes, at the back. So the question was, can you knock another team's blocks of towers down? Yes, I'm going to say yes, that is a strategy. So if you want to, go on full on Myri Cyrus and walk around the arena knocking everything over with a giant wrecking ball, you could probably do that because obviously that will allow you to steal the highest point token designation. We do have a section on our rules that say that you can't be malicious about it, basically. So if you want, you can review your mechanism with us before you fully implement it. Yes. The size. So the question was, what are the size dimensions of the robots? So I'm open to be corrected here. I believe it's a 50 centimeter cubed on all sides. Yes. So the length, width, and height has to fit within a 50 centimeter cubed. Sorry? Vertical heights. Jake. Yes, thank you. So the clarification there is that before the match starts, the robot has to fit within a 50 by 50 by 50 centimeter cube. But after the match starts, along the length and width, it can extend to 60, and the height is unlimited. Did I get that right, Jake? Yeah. Yes, fantastic. Anyone else? You there at the front. Correct. So the question was, the deadlines that were displayed earlier, are they specific to any challenges? And I believe here the answer is no, you can complete them in any order. We still do not have any questions coming in over the on because it's broken. I'm very sorry about that. Yes, please. Can you stack on the top of other people's high rises? Yes. What if you place your pallet on another person's pallets? Well, depending on what else is going on in that district, you could potentially seal the highest pallet designation from that team. Can you use your robot to gain height? No, because as I said before, the one of the exclusions is that the pallets must not be touching the robot. So you won't be in. So you can lift up the pallets using your robots, but for the pallet to be considered the highest, it must not be touching your robot at the end of the match. We have another in-person question at the back. So the question is, what are the dimensions of the pallets? Again, this is not one that I know off the top of my head. These will be found in the rules. Do any of our blue shirts know? 130 millimeters cubes. We have another question at the front. So the question was, is you get, I mentioned that you get 6 league points per challenge. Is that just for each challenge, or can you repeat the last part of your question, please? Or are you going against other teams? No, it's per challenge. It's you individually get 6 points for every challenge that you can submit before the deadline, I want to say. Yes. Remote question. Fantastic. It's a mistake on my slides. Ah, tell me. Oh dear, I just got fact checked on my own presentation. Fantastic. So the the fact check was that apparently in the rules the center district is worth 3 points, not four. And I yes, that is correct. The center district is worth 3 points, not four. My apologies. I used an old version of the rules when I was making the slides, so that's on me. Um, there are more questions. Well, there are more questions. There are fantastic. No, because well, it depends. Okay, sorry. It depends. If the pallets with the height of one is not on a robot and it is on a high rise, then it could potentially be considered the highest in the district, if that makes sense. Sure. Oh no, I know where this is going. I know where this is going. Yeah. So the question was, what if you threw up what if you threw the cube up, the pellets up at the last second? Would that be considered to be the highest? The answer is no. We added that as a last minute change. It was a pretty funny. We're on a Teams call reviewing these slides, and Peter, one of our volunteers, came up with that scenario. So very quickly excluded that from the rules. So the answer is no. The pellets must be in a stable state at the end of the match. We have another question here at the front. Hmm. Hmm. Yes. So the question was, if you've placed a pallet on top of another pallet within a district, can you then pick up that pallet and move it to another district? And the answer is yes. So it's only where they are at the end that counts. Yes. So the question was, are you allowed to alter or change the position of other teams' pallets? Yes, absolutely. Another question. Sorry, can you repeat that, please? Hmm. Yep. Mhm. Yep. So the question was, if can a robot use other teams' pallets in order to put their pallets on top of in order to gain the highest pallet designation? Yes, is the answer to that question. Yes, that's a good point. I just got Antoine just helpfully made an addition. If you then take that pallet stack and take it into a scoring district, you're inadvertently giving other teams points. But the trade-off might be there. In order to gain double the amount of points, you might consider that to be a worthwhile trade-off. I think we had another question here on the left, maybe. So who would get the Yeah, so who would get the score in that case? Both teams would get points, but the team that has the highest pallet would get double the points. Yep. So the question was, can you deposit your own support for a box? Can I don't understand. What do you, sorry, what do you? Ooh, could you stand by, please? So the question was, can you deposit a part of your robot and use that as a foundation for the highest pallets? We're just checking the rules right now. So we think no. We will confirm this and post it in the Discord later. Yes. So the answer is probably no because that would be considered part of your robots. And as we said earlier, pallets touching your robot will not be considered in the highest designation. We have another question. Oh, so the question was, how heavy are the pallets? I Does anyone hear blue shirts? About 100 grams. They're an empty cardboard box. So the second question is, can you stick pallets together? As in, you can place them together side by side, yes. I'm. If we assume they mean glue, probably not, or definitely not. We don't want you to be damaging our lovely arena props. So the question was, how many of each color palettes are there? Six. We have another question from Discord. So the question was, can you tell the box color from the markers? Yes, you can. Right then. Nothing in YouTube? Nothing in person? Fantastic. Should we let's round it off there then. Fantastic. Thank you very much to everyone who asked the question, and thank you very much to everyone for giving me your attention in person and online. And the last thing to say here is good luck and have fun. Thank you very much for joining us today for live stream for the Kickstart of Robotics 2025.